Welcome, everybody, to the Daily Space Weather. We've got a filament fest continuing here. Lots of likelihood of additional coronal mass ejections headed Earth's way. There's already one headed Earth's direction. We can expect to see that arrive mid to late day on Wednesday, January 18th. And thanks for tuning into the Smash News Network, least busted name and news, as we just bring you the most detailed imagery and comprehensive space weather you'll find in the known universe. Again, filamentary fest going on. The radio flux has reached a new high in solar cycle 25. Let's take a look at some more filaments, as this is the Dick Van Dyke filament right down here. Here's the Ye filament, named for the artist formerly known as Kanye West. We've got the Renee Gable filament setting up here around the North Polar region. Heading down to the southwestern limb. Yes, we've been naming filaments after living people, so that's pretty sweet. We've got the Zach Toven filament here setting. Liver King filament over here. We've got the Dan Nigro filament over here. And let's take a look at the most newly named filament. It's the Dick Van Dyke, which is this one up here, I believe it is. See our Twitter feed for the full breakdown of named filaments. Yes. So we've got lots of sunspots. We saw the sunspot number exceed 200 there for a minute. And this pair of sunspot groups up here is spectacular. We've got another named group forming here since yesterday. So this data is yesterday plus today. There's a new group forming right up there in the northern hemisphere. Let's see how it looks in colorized magnetogram. So mostly stable here as far as sunspots go. Let's go back to the intensitygram for a brief moment. This sunspot down here appears to be growing a bit. And this group here is growing as well. So despite a slight decrease in the X-ray flux, solar activity looks like it is maybe leveling off, but perhaps continuing to increase here as the exciting solar cycle 25 continues. So let's see what's exciting as far as volcanoes. By the way, that's Villarrica's lava fountaining from Saturday. Let's see what else is erupting. It includes Semeru, producing a 14,000-foot ash plume as it explodes on East Java, Indonesia. Popocatépetl also exploding, flight level 210. 21,000 feet of volcanic ash over central Mexico. Fuego in Guatemala exploding, 16,000-foot ash plume. Sangay exploding, 20,000-foot ash plume, flight level 200. Do not fly your John Denver-style ultralight aircraft over the caldera. Revenador exploding, flight level 160. Sabancaya continuous emissions from Sabancaya in Peru. And Villarrica, again, lava fountaining happening down there. A paroxysm, otherwise known as a strong eruptive episode, took place, and yeah, that's the volcano rundown. Let's see what's going on seismically speaking. There is the past 90 days in convenient bar graph form from volcanodiscovery.com. And we have had 2 6+ magnitude quakes in the past 24 hours, putting our seismic activity level at high. So there's the older of the 2 6+ magnitude quakes, that one taking place just off the coast of one of the isles of Indonesia there. That was a 6.2. It came in at 22:29 Universal Time last night on the 15th. And there's the other 6+ magnitude quake, that one occurring south of Japan at 4:49 Universal Time this morning on January 16th. That was at over 400 kilometers depth. And let's run up the list here. If we miss anything, let us know in the comments. Vanuatu had a 5.6 in the past 24 hours. There's a 5.0 at the Fiji Islands area there at over 570 kilometers estimated depth. Again, that 6.2 at Indonesia came at 22:29 Universal Time. El Salvador also had a 5.2. Keep in mind, folks, any earthquake can be a foreshock. Let's hope those 6 magnitude quakes are not foreshocks. Again, that 6.3 south of Japan was at over 400 kilometers estimated depth. Also, Chile saw a 5.0. And let's get back to space. There's plenty of action out there. So yeah, we bring you the most detailed imagery you'll find any place on the internet of the closest star. And we're not just a paper tiger here. We are bringing you in-depth information here, not just oohs and ahs. But we're writing a paper explaining the solar sunspot cycle mechanisms. And yeah, it's pretty serious. Anyway, that's 131 plus 171 angstroms. Here is 171 plus 211 angstroms, showing some different portions of the solar corona there. All of these wavelengths are ultraviolet light. I would remind our viewers that we do indeed have a filament fest coming. Mike Bordaja says 8.0 soon come. Let's reiterate that any earthquake can be a foreshock, folks. So be an asset, not a liability in the event of a disaster, we hope. So let's take a look at some more data here. The 10.7 centimeter radial flux now at 234 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 joules of radial flux density. It comes out of the upper chromosphere and lower corona, about where my pointer is located. And it's the most proportional data set we have to sunspot number. Check it out. We're going to have the scale expanded here at solon.info. Radial flux now at 234 solar flux units. I think the sunspot number is going to rise up again here. But in any case, there you go. There's the 1 year graph as we sit at new highs for activity for solar cycle 25. Now, NOAA is forecasting some geomagnetic unrest today. It looks like that warning is actually subsiding here. We are expecting some geomagnetic unrest sometime around this period. Sometime after midday universal time on the 18th. So somewhere in here we are expecting some minor geomagnetic storm conditions from a coronal mass ejection impact. I think there may be a little bit of a disparity there in the forecasts, but that's our forecast. See our videos from the past couple of days for additional details on that. Planetary K-index currently at 3. It is a geomagnetically calm conditions. Let's take a look at Earth's magnetic moment from space. So here's the last 4 hours of Earth's magnetic moment out to about 12 Earth diameters. We have had some minor coronal hole high-speed streams here coming through. There have been some aurorae generated for sure. And if you've got imagery of the aurora, or frankly anything that relates to space weather, or even meteorology, drop us a line on Twitter or perhaps on Instagram. We'll be happy to feature your content on the channel if it's good. So here's the last 4 hours of Earth's magnetic moment from the ground. These are the most likely places to see the aurora. Also pipeline, railway, and power line induction. Where those red zones are, that's delta B. Geospace delta B changes to Earth's B field. Next, looking at the real-time solar wind. Keep in mind this is measured at Lagrange 1, about 1 million miles away from Earth. Because we can't measure it from an earthly orbit that is inside the magnetosphere. These spacecraft are outside the magnetosphere at Lagrangian point 1. Current conditions are about 8.2 protons per cubic centimeter. Solar wind speed about 473 kilometers per second. Fairly unremarkable there. And let's look at magnetic data. There are your GOES magnetometers. And these spiky readings here are typical of a coronal hole high-speed stream or two. And let's take a look at the heliospheric current sheet next. It's fairly orderly here at the moment. On the opposite side of the sun, we've got largely a south pole current sheet. And on the earthly side of the sun, we've got largely a north pole current sheet. A little bit of indecision happening right around this area, but it's only minor. Just an indication that the south pole current sheet is close by, close to the ecliptic plane. That's the plane on which the planets orbit the sun. And let's take a look at the line of sight field plot next. We've got a lot of north pole solar magnetism here rotating in. shown there in green, south pole magnetism shown in red, solar B field shown in blue, which brings us to coronal holes, perhaps the most important feature of a solar cycle. We'll tell you why when we publish our paper. When it passes peer review, it will be one of the most important papers in a couple hundred years. So this is our line of sight coronal hole plot. You've got North Pole-oriented coronal holes rotating in here depicted in green. I would also note a lot of North Pole magnetism hanging out around the North Solar Pole. An indication that there is a long way to go to reach solar maximum, because at solar maximum, you wouldn't expect to see any original magnetism hanging out at the pole. So we've got South Pole magnetism down here. We've got North Pole magnetism up here at the North Pole yet. There is a long way to go for the field reversal process to be completed. Nowhere near solar maximum. We're still a couple of years out, so expect the activity to continue to increase. There is the last 24 hours and 211 angstroms. Again, these are North Pole-oriented coronal holes. We can expect a high-speed wind from that in about 3 days. 3 days and change. So sometime on the 19th. Right after the coronal mass ejection strike that we forecasted shows up. Next, we'll look at sunspots. A similarly important feature to sunspot cycles. Again, I think the coronal hole solar magnetic field reversal process is more important, but check out all the sunspots. That's a lot. And we can expect to see at least one more named group. It's right up here. That'll be known as 3195. 3195, I believe, will be the name of that new sunspot group. And let's take a look from SDO's perspective. There is the last 24 hours, and let's zoom in a little closer here. That was insufficient detail. So at least one more named sunspot group. Again, the radio flux sits at new highs, 234 solar flux units. Here we've added 304 angstroms to add a little character in the form of ionized helium. Flaring has dropped. We'll get to that next. There's the past 24 hours in full disk glory from SDO, 304 angstroms plus SDO continuum. More trans-equatorial plasma exchange happening there, right over here. And let's continue on to energetic particles. No spikes in the proton flux here for the past 3 days. We've only had a minor one in the past 7 days. It was barely even, didn't even make it to warning threshold levels. Probably caused very short-lived polar radio blackouts, no big deal. Now, here's the 7-day graph of the X-ray profile. And you can actually see it dropping here. The peak was sort of on the 12th. And, of course, we had a couple of X-class flares here, including this one on the 10th. At the moment, the X-ray profile has been dropping. So let's take a look at some top-notch wavelengths. There is 131 angstroms. Looks like the main flaring location is this sunspot down here, and it is certainly huge. How about 94 angstroms? Good stuff from SDO. And I just want to check on something here. Did I forget to put something up? I may have forgotten to put something up, folks. Just bear with me. I don't want you to miss out on this imagery. It is splentacular. We'll include it here in the solar flare section before we show you a star chart. So we decided to bring up 171 plus 131 angstroms, because we got this great zoom in on the eastern portion of the solar equator. Again, since there is a little bit of a plasma exchange happening there, We brought up the two wavelengths that are probably best at showing magnetic looping. That is 131 plus 171 angstroms. Let us know in the comments if you think that's the money shot on today's video. Pretty sweet indeed. Pretty sweet indeed. And let's take a look at a star chart here, as we're always interested in what's going on overhead. So this is a different star chart than we usually use. And we've put our view here towards Cygnus, Deneb. It's, of course, the brightest intrinsic object visible from our solar system. Were you aware? We've also got Mars and Jupiter up there in the sky. This star chart is from Sky and Telescope. skyandtelescope.org. So that one is facing to the north. That is what it's looking like over Lehigh Valley, Pennsylvania. And let's do a solar system forecast next from theplanetstoday.com. Keep in mind this imagery is not to scale. Here's your 1 week forecast. And in 1 week we will have a crescent waxing moon. A little tiny sliver will be appearing in the early morning sky. Next, looking at coronagraphs. Do we have any additional earthly directed coronal mass ejections? Here are 100 frames from yesterday, and the answer is not really. So here are the rest of the frames from today. And quite sure none of those coronal mass ejections are earthly directed. Let's see if we can get a little more detail from Stereo A at Lagrange 5 and Soho Lasco C3 at Lagrange 1. Here's Stereo A on your left, Soho Lasco C3 on your right. For you new viewers, Earth would be off in this line from Stereo A's perspective, and it would be behind you from the perspective of looking down the Soho Lasco C3's coronagraph. Of course, we are seeing that CME there that has the earthly directed component. So there's one CME confirmed on the far side of the sun. Nothing on the Earth side of the sun. So that's just a light show there, folks. Nothing headed your way. Except the CME we expect to arrive on the 18th. And of course the Corona Hole high-speed stream we expect to arrive on the 19th. So there are some fireworks in the future. Hopefully, maybe we'll see some mid-latitude aurorae, causing people to get unnecessarily frightened of space. That's the last 24 hours, and we'll zoom all the way out to show the full extent, almost the full extent there, of the Soho Lasco C3. Which brings us to filaments. Again, we've got a filament fest happening. Let's take a look at that. This is the El Teide, Spain ground-based solar observatory. So again, you've got the Rene Gable up here. You've got the Ye. You've got the Zach Toven. This is the Liver King. Here's the Dan Nigro. Then we've got the Dick Van Dyke up here. And there is a new filament forming up here. So let's bring up the latest image. And once again, we'll tweet right here on the live stream. So, yeah. It's another episode of Wait for Twitter to function. Wait, I got an idea. Let's wait for the censorship to end on Twitter. No, that's okay, Elon. We'll wait. You just go ahead and end the shadow bans on Twitter, and then maybe you won't be misleading investors. Sound good? Name that filament. And if you want to actually name the filament, you've got to do it on Twitter. Again, it's this filament up here. This one right up here in the north. That one needs a name. We name filaments after living people on the channel. Join us on Twitter to do so. And here's the last couple of hours from the Go 16 SUVI, which we streamed for over 15 hours on YouTube last night. We decided to do a lengthy YouTube stream instead of a Twitch stream. We regularly stream this all day on Twitch at twitch.tv/smashomash. Interestingly, this video was originally streamed there, and let's take a look at the last 24 hours from SDO. Here's our 304 plus 193 angstroms wavelength. Fantastic at showing filaments. It really shows a three-dimensionality there to the solar corona, as there is certainly a lot of stuff going on there that is not evident from the ground level. And let's move into our bonus features segment. So we've got some satellite charging hazards here. Similar to yesterday, we've got surface charging hazards there in the Central Pacific. Those are caused by low-energy electrons on the outsides of satellites. Central Pacific surface charging hazards are the scenario. Electron flux has come off the floor a little bit here before dropping back down. It did briefly reach into warning levels, at least for the GOES-18's measurements. Those measurements are radiographic measurements, by the way, from their geosynchronous orbits. They're at like 22,500 miles of altitude. They're measuring the electron flux at the F layer of the ionosphere, which we'll show you here next. First, some context for the relativistic electrons. There is the forecast. That's the NOAA forecast depicted by the green boxes. And there's the one-year chart from solon.info, slowly climbing up here to more normal levels of electron flux. And let's take a look at the F layer of the ionosphere. That's the bridge between Earth and space, located at about 300 kilometers of altitude, and there is the vibrational frequency. So massive anomalies happening here. We're seeing both high and low frequency anomalies all over the planet. And if those aren't evident from this imagery, the anomalygram will make it a little more obvious for you. So let's bring that up next. There's the anomalygram. That's anomaly in megahertz from a 30-day median. And this is probably the most significant series of anomalies we've ever covered on the channel in terms of the ionosphere. Most of the entire northern and southern hemisphere there being dominated by high or low frequency of anomalies and rapid swings. That is the anomaly in megahertz from the 30-day median. And that is highly anomalous. I don't know what else to say. If you're sounding the alarm bells because of anomalies in the ionosphere for earthquake forecasting, not so sure if that works or not, but it might be time to sound the earthquake alarm bells if you believe the ionosphere can forecast earthquakes. So hopefully that's objective enough and I haven't offended anybody, or maybe I have offended. Hopefully I have offended the people that I want to. Anyway, there's the latest image. That's 12 o'clock Universal Time ionogram. And there's your 12 o'clock Universal Time anomalygram. And yeah, significant anomalies there of both the high and low frequency variety. And let's move on to the electron content. So the electron content also highly anomalous here. Lots of free electrons sort of out of place, out of where you'd expect them to be. This imagery depicts the free electrons between your GPS satellite and your GPS handset. That's about 12,500 miles of free electrons. And check out the polar anomalies there in the North Polar region. Electrons hugely out of place here, and it's been going on for over a week. Total electron content here showing us that there will be massive GPS errors over most of the planet's population, actually. So perhaps turn on your Wi-Fi accuracy if your GPS is off by hundreds or even thousands of miles, as I've done bike rides when I had significant GPS errors. And for example, one day I had an alleged average speed of over 10,000 miles per hour. That's what happens when you have GPS errors, and there are lots of them around the planet right now. Next, our latest high-res imagery. So here's this new sunspot that'll get named today. It's pretty small compared to what else we have. And it is beta gamma class. In fact, you could even make the argument that it is currently beta gamma delta class. The rest of these groups are just huge, and especially this group down here, spectacularly gigantic. DAG. That's one of the largest single umbrae of the entire solar sunspot cycle, and it is beta gamma class. And it looks like we've got another sunspot we've got another sunspot rising behind it also. So here's another new sunspot right back here. Right there. So at least 2 new sunspot groups showing up there. If you were expecting a solar cycle with 0 sunspots, think again. That's not a thing. And that is a lot of sunspots and a very high radio flux. So yeah, that right there is where the space weather section ends. And if you're wondering what this is, that is the core of the Milky Way galaxy. The little blue dot you see there, that's Sagittarius A star, the massive radio source at the core of the Milky Way galaxy, around which a bunch of blue supergiant stars orbit. Of course, it is a very chaotic area indeed. And yeah, Milky Way galaxy team for the win. And before we get to our meteorology segment, you are all invited, of course, to join us at the Smash Team site, smashomash.com/Smash Team. We've started sending out email alerts for our basic space weather and meteorology videos, our routine daily content, because people don't get notifications on YouTube. Yes, YouTube, otherwise known as Junkware not sending notifications to people, not recommending the appropriate content, and of course promoting fraud, propaganda, and nonsense, misleading investors, etc. YouTube, we insist that you repair your software. Of course, YouTube is the only video hosting site that has over 1 billion daily users, which makes it a legit monopoly. It is not acceptable to switch to Rumble or any other location because those locations do not have 1 billion daily users. Anyway, so sign up for email alerts if you like. If you want to support the channel, become a gold or silver or annual gold paid up subscription member at the Smash Team. Smashomash.com/Smash Team. The best value is the gold annual paid up subscription, as it includes complimentary merch. We are still on Patreon as well, so if you want to support us that way because it's too inconvenient to sign up for a new website, well, we still are on Patreon. Keep in mind we make just this side of nothing to put the content on YouTube, thanks to the pathetic and putrid censorship on the platform. Why? Because reasons. So if you haven't checked out the merch below the video, there's a link right down there. It'll show you the merch in order of best selling. And we started putting out merch a few years ago because reasons. Because, well, we've got things to say. And since a lot of people are unable to hear the things that we have to say, we decided to put out some merch. So give Smash staff a raise, perhaps. Pick up some merch because reasons. Why is there so much fraud on planet Earth? Why is there so much corporate nonsense and unbelievable, terrible decisions? Because reasons. Again, if you click the link below the video to the Red Bubble Shop, you'll find the products in order of best selling. There's a quick rundown. They may or may not review. They may or may not reflect the political stance of the Smash News Network, least busted name in news. Thanks, YouTube viewers, for putting up with the pathetic censorship on the platform. Press like, subscribe, share, etc. if you haven't. If you're a new viewer, thanks for tuning in. Congratulations on realizing the channel exists. Frankly, we are surprised that you have. Check out our playlist for lots of videos besides space weather and meteorology. And welcome to the Neo Renaissance. Congratulations once again on realizing that our channel exists. It's only the most detailed imagery of the sun and most comprehensive space weather you'll find anywhere in the world. Our own website is smashomash.com, and welcome to the Neo Renaissance. We've made some massive changes and more to come over there, and it's time to chase the world's largest waves. Yes, I'm a wave chaser. I'm not an ambulance chaser. I'm a wave chaser. We've got enough ambulance chasing noobs on YouTube, so let's chase waves instead. Looks like the largest waves in the world are about 27 footers in the Southern Ocean, where there's nobody to enjoy them. One place where there might be larger waves here is off the tip of Greenland. What do we got? We got larger waves in Greenland than in the Southern Ocean. There we go, nearly 30 footers there. And what this map is depicting is surface winds as well as significant wave height. So some high seas there in the North Pacific as well. And also it looks like some good surf there around Portugal and Spain, perhaps. Anyway, here are the surface winds of the eastern world. As we bring meteorology home, surface winds are like that. Jet streams are like this. Jet streams of the west are like this. Surface winds of the Americas depicted here. Surface winds of the central world here. And perhaps the surf isn't too good at Spain and Portugal because we've got an onshore wind, and offshore wind makes for better waves. Last but not least, there is the jet stream scenario for the central world. And let's move on to see clouds and fog over the Americas. That's what's going on Croissant Earth, at least on this west side. Shout out to the west side, shout out to the east side, shout out to the central side. That's shortwave radiation in the infrared band of 3.9 nanometers. Here's your weather.gov map. If your location is lit, click your location. We've got a bunch of cold weather warnings here across the U.S., including some hard freeze and frost advisories over much of Florida. We'll show you some forecasts here coming next. So let's start with the temperature anomaly forecast. There is your temperature anomaly based on degrees Celsius for the next 72 hours. It is the GFS model. So cold temperatures west of the Mississippi, warm temperatures moving east of the Mississippi. The most anomalously warm days will come to Tennessee and Kentucky, actually, where those see temperatures 20 degrees above normal there in the next 3 days. We'll also show pressure and precipitation. And there is some ice coming to the Great Lakes region and portions of New York. Lots of precipitation coming for California as wave after wave of moisture continues to come in from the Pacific. Here's your GFS total accumulated precipitation forecast. This is precipitation in inches. It is also based on the GFS model. And since some of that precipitation will fall in the form of snow, let's also show the total accumulated snow depth change in inches. Also the GFS model, also the next 72 hours. That's what's going on there. It looks like additional snow and rain coming to California. California, a great experiment on what not to do in terms of your state government. Next, looking at our windy.com map, and this is going to be the Euro forecast for snow. This is our snow accumulation for the next 12 hours. Heavy snows there coming to California and to Maine. There is the next 24 hours as that system in the west moves to the east. And there is the next 3 days. Nebraska is going to be completely blanketed according to the European forecast model. That is from windy.com. They've got a great mobile app. Perhaps install that if you haven't. And we've got continued lightning in the western Atlantic. So as that low moves off to the east, the lightning follows on its leading edge. And let's check and see the current strikes. There is lightningmaps.org. We've got some terrestrial strikes here right in the center of the country. Western Kansas City. Hey, Kansas City, there's thunder rolling in. Some lightning there showing up right as we do the stream. Remember, folks, lightning strikes twice. Lightning absolutely strikes twice. Don't assume it doesn't. If you see lightning strike an area, don't go stand in that area. Lightning does strike twice. What if there's a huge conductor underground, like a giant magnetite rock that you can't see? Lightning indeed strikes twice. And be on top of it with lightningmaps.org. Next time you hear thunder, you can convince the natives that you're Zeus or something like that, perhaps appear to be a horror movie villain, by saying something foreboding as thunder rolls in. That's the current state of affairs. Small little thunder shower there around Kansas City. Moving to the east, it looks like. So just east of Kansas City, we've got that. And we'll close things out with some more real-time imagery. This is our U.S. Doppler radar map. Precipitation continues in southern Alaska. And Chicago, there's some heavy moisture headed your direction. Here is shortwave radiation showing clouds and fog. You can see that low moving it's actually moving a little bit southeast is the new track of that low. Lots of low clouds behind it there as well. And last but not least, there is water vapor. That is where we will close this video out. It's the recap, starting with U.S. Doppler radar. Moving next to shortwave radiation showing clouds and fog, as we see a low encircled by dry air moving into Iowa and Missouri. It might be more obvious on the water vapor map. There you can see that low. It is encircled by dry mass of air, which does not help to strengthen it. But there are still some huge pressure gradients being created there. And that is where we must end the video. So thanks for tuning in. Congratulations on realizing that the Smash News Network least busted name in news exists. Milky Way Galaxy team for the win. And may that solar wind be at your back. Facts stated in this video, not necessarily the opinions of Smash News Network least busted name in news.